Okay. Alan, I think the time is yours.
Check
Please take
one,
it
two.
away.
Okay, fantastic. I'm just gonna wait and looks like yes. Okay, people can hear me. Fantastic. Um, all right, so I'm going to start off just by telling you what I am up to with this Wii U that I have sitting beside me. Um, I've developed. I'm just kind of have a method of testing HDMI audio delay using a Wii U, and that's what I'm going to be presenting tonight. It's kind of like a games adjacent thing. It's not really a game, but it's relevant to video games. So maybe some of you might find this interesting. So just to start, some of you might be familiar with video input lag. So that's like the delay that a monitor, a TV might add to the video signal that can sometimes affect the game feel of a video game. It also affects rhythm games, for example, like Guitar Hero or things like that. So that delay, especially actually motion controls end up being a big problem, or like mouse controls with video when you have a large video delay. So measuring input lag, that video delay, is actually quite common, and there's sites like ratings.com that has a massive database of all types of like the input lag for all types of TVs. And the thing that I found is that there isn't really much testing or documentation on audio delay, or audio input lag. So because of that, I thought I'd kind of explore a bit of like hobbyist level audio delay measurement, just so that I could test it myself without going through the process of developing a bunch of custom hardware. So audio delay is also it's important because if your audio delay doesn't match your video delay, then you get lip sync issues, and you can see that just in video. So maybe you put your TV onto game mode, and your video delay is only a couple milliseconds, but your audio delay, let's say that's like 90 milliseconds. And this is exactly what happens on my brand new TV that I just bought. Has like a 2 millisecond video delay, but a 90 millisecond audio delay, and that's enough to actually start noticing lip sync issues. So yeah, big deal for game mode on TV. Yeah, so that's some of the reason that that's important. Also, in terms of esports, your perception system inside your brain is able to react to sounds faster than it's able to react to video. There was a article that I dug up at somewhere that was did some actual research on that, and you are able to respond to audio cues faster than visual cues, which makes sense because the audio is a much simpler thing for your brain to understand than video visuals. Yeah, so in terms of esports, having fast audio is important as well. So previously, in terms of hobbyist testing for audio delay, people would use the Guitar Hero or the Rock Band Stratocaster. So this guitar actually has a video like input lag tester, as well as you can see if I hold it at just the right angle, there's actually a little hole right there, and that's a microphone to use for audio delay testing. And with this, I actually tested this guitar on a monitor that I had, and then also on an old CRT TV, because the Xbox 360 output to both HDMI and the old analog RCA output. And the analog RCA output did measure at like 0 millisecond latency latency on a TV, which is what I expected. But it wasn't able to output to both at the same time. And so years went on, and now there's newer consoles, and I found that on the Xbox One, the Stratocaster, when you use the Stratocaster to measure audio delay, it would have 80 milliseconds added, just kind of as a base level latencycycy see. So it wasn't actually good for being all that precise, and it was also not very accurate either. You get a lot of variance on it. So anyway, there was a lot about that method that wasn't great for latency test or delay testing, audio delay testing. But then I discovered that, the Wii U can output both audio through both HDMI and the analog, like the RCA plugs, if you can see that there. And so because it can output both at the same time, then that means that you can use that Wii U as basically a signal generator and compare the audio output in terms of time, just from one source and then also from the other source. So in order to record that signal and the difference between those two times, one being the HDMI as it passes through, let's say, the DAC that's built into a receiver or the DAC that's built into a monitor, and then down into your actual speaker output or your headphone output or something like that. You can compare that to the analog Wii U output just by using a sound card and hooking up one input into the right channel and the other input into the left channel of the audio. So that's what I've done here. I have this audio interface. So I'm just going to pull some cables out so you can kind of see. Yeah, so I've got my my Wii U output. It goes into this cable into the left channel of my PreSonus audio interface here. And then the right channel, right now I've got this hooked up to just the headphone output of this monitor. All right. So I can now record this audio, and I'll just show you in Audacity here. So I can hit the record button, and I will record audio as it's coming through both the headphone output, which is of the headphone output of the monitor that I'm using here, which is the bottom channel. That's the right channel, and then the top channel there is just the original Wii U audio going through the RCA. Now, when I'm on this menu here, I can just like page back and forth, and it'll make these nice little tick sounds, which make it really good for testing audio latency. Because they're easy to see, so I can just zoom in here. And we will notice that there is a small bit of a delay when I'm using this monitor. So one of them here is a little bit earlier. That's the Wii U, the original Wii U, and this is the monitor. We have 258 samples at 192 kilohertz. So then if I just punch that into calculator here, so that was 258 out of 192,000. So that there is 1.3 milliseconds. So 1.3 milliseconds is incredibly good. That's super, super fast. It's not really the kind of delay that you'd be able to notice. But let's try something else. Let's try this Sony receiver. So for the receiver here, if you look over here, I've got the just an old telephone wire hooked up directly into the speaker output of my receiver, which I can then just plug into the right channel of my audio input. And let's do the same test. Here we go. So how do I use Audacity? Is this going to make a new track? I think it will. Oh, fun. That's new. Okay, I just need to close this, reopen it. Okay, we're up and running again. Good. Audio issues, that's the theme of tonight. Okay, so now I'm recording the receiver's output. Let me just make that a bit bigger for you. So now when I page back and forth, I get these nice little ticking sounds. And I'll stop that. I will zoom in. If you remember the last time, it was 1.3 milliseconds. And you can already see here, if you remember what the other one looked like, that the delay is a lot more substantial going through this old Sony receiver. So I'll do the same thing, and I'll find that right there to all the way over here. And we find this is 10,000. Open up calculator. So we have 10,890, sorry, 839 samples at 192,000 samples per second. So we can find here that that's actually 56.5 milliseconds. So we have the difference of, we're looking at a full 55 millisecond difference between the headphone output of this monitor and the receiver that I'm testing here. Yeah, so this is basically just a hobbyist way of being able to test the audio delay of your different devices. And this can be really useful for esports and just like making sure that lip sync is actually all good to go for your game mode on your TV, things like that. Yeah, that's basically the gist of it.
Cool.
I'm rushing to unmute. Alan, this is so cool.
Yeah.
Dope. I'm into this.
Yep, just wacky uses of a Wii U that probably nobody was anticipating.
Fancy pantsy. Yeah, there's sort of almost like a tradition of people taking, I think originally the Wii, but also you're using the Wii U here as well, and just using the sort of plethora of fun sensors and stuff like that it provides to create neat homebrew stuff like this. I don't know if you remember those old YouTubes. I wish I could remember the name of the guy, but he was doing a lot of experiments with it, like creating like light pens and stuff like that, just using like the pieces of the Wii in sort of like often sort of like unconventional ways, like kind of like using them backwards and stuff like that, like taking the sensors from the sensor bar and then putting those into like a pen or a wand or something like that, and then kind of like doing everything backwards, sort of.
Yeah. I could see that.
Hey, I have a quick question, Alan.
Sure.
So you've tested this Sony receiver. Have you tested anything that's been worse latency than that? Do you have like a hunt to do? I'm curious now, like how bad does this?
So this originally did start with me just wanting to get a receiver for my TV. My TV itself had pretty bad, on just its speakers, had pretty bad delay. I described there it was over 90 milliseconds for the speaker delay when I'm in game mode, which is weird because it's very low latency on the video. I found the Yamaha receivers were the worst, of the ones that I tested. I also found that with the Yamaha and Sony, you'd get like 50 or 60 milliseconds of latency in a stereo HDMI signal, but you switch it to a 5.1 surround signal, and suddenly it drops down to 17 milliseconds of latency. And these are like notable differences here. I think it's about 100 milliseconds is when like the average person's going to notice lip sync issues. So when you're talking about 100 millisecond difference between your video latency and your audio latency, which is what my TV does, like that's a big deal. So I tested a bunch of receivers, made good use of Best Buy's return policy, bought open box when I could. So I was very surprised to find the monitors, they were like exceptionally fast, and the fact that I'm getting monitors that are measuring in at like 1 millisecond or basically 1 millisecond, that kind of shows that this test might actually be pretty precise, because it matched what I was seeing with the original Rock Band 360 Stratocaster's measurements, which seemed to be pretty well calibrated. So yeah.
I love this. This is so cool, Alan.
Yeah, thank you.
Wacky stuff. I also have a blog post that has a lot more detail about this whole process. So I'll post that in chat, like right now.
Awesome. Thank you, Alan. This is amazing. Please, when you come up with more wacky stuff, we would love to see it.
Yeah, of course. Thanks for having me.
All right.
Thank you.
We'll be back with our next presenter of the night. Don't go anywhere.